Hello and welcome. Today we will be talking about a Flying Dagger 3D printable glider designed by myself, Daniel Gamble, and Fusion 360 for a project for UAT. Now, this aircraft is designed to be fabricated on a standard size 3D printer in 6 separate components. Once printed, these parts can be assembled and bonded together to create a fully launch-ready model. Now this model is designed to look kind of like a throwing dagger, so it should just sort of cut through the air with its body shape. It doesn't need to be too bulky. It also reminds me sort of like a flying fish with these wings. Nice little gliding action. Now, this drawing here is showing ABS plastic as our material. However, it can also be printed in PLA, PETG, or TPU, and even a different material for each component if desired. The wings and horizontal stabilizers have a slot to locate them on the fuselage for easy attachment. The nose will be inserted into the front and glued in. It should be printed more dense than the rest of the plane for stability, and it could even benefit from being printed in TPU for extra durability. As illustrated, the glider features a relatively wide 17-inch wingspan for its size. The wings are set at a 5-degree dihedral angle from the fuselage and are aerodynamically shaped to enhance lift generation. The fuselage is aerodynamically streamlined to minimize drag and is sufficiently slender to integrate seamlessly with the launcher mechanism provided by UAT. Stress test simulations were performed to determine if our plane will withstand the proper forces required. The initial test was conducted to evaluate whether the wings could withstand the generated lift. Given the model's small scale, it is not expected to encounter any issues once the wings are securely attached. The next stress analysis evaluated whether aerodynamic drag could impose loads on the wings that might lead to structural failure. Based on the anticipated launch velocity, the wing structure demonstrates adequate strength to withstand the applied forces. The final evaluation assessed whether the launch hook is capable of withstanding 12 newtons of force during takeoff, as this represents the maximum load the aircraft will experience throughout the flight. It is essential that the component possesses sufficient structural integrity and durability to make this happen. This image illustrates the distribution of forces acting on the launch hook during takeoff. Based on the analysis, the hook is capable of withstanding forces significantly greater than the required load before reaching its failure threshold. Each piece is printed with 3 walls and 0% infill with the exception of the nose. It is printed between 50 to 100% infill depending on material used. But once assembled, we are ready to launch. Thank you for watching, and I hope you enjoyed this presentation.